In this video, we're continuing section 6.1, and we'll talk about special right triangles. Okay, so the first type is a 45, 45, 90 triangle. And I'm going to draw two pictures of these. Okay, so I'm going to draw one general picture. So 45, 45, 90 means there's one 90-degree angle, and the other two angles are both 45 degrees. So 45 here and a 45 here. So in my general picture, I'll just label the hypotenuse as x. I'll keep it general. And in this other picture on the side, I want to draw a picture where the hypotenuse equals 1. Because that might be a different sized 45, 45, 90. But still, there's one 90-degree angle and there's two 45-degree angles. Okay, and the hypotenuse is 1. So one thing I want to observe about these two triangles is all of their angles, correspond and they match up. They have equal measure. So these two triangles are similar. They are similar. We got some similar triangles. Okay, so that's going to help me get the sides. If I can get the sides of one triangle, that'll be quick to get the sides of the other one. All right, so let's begin by getting the sides of the general triangle, the general 45, 45, 90. So if the hypotenuse is x, let's try to get the other sides. So these are called the legs. So I don't know what this is. I'll maybe call it A. And if that's A, because both of these sides are opposite the same angle of 45, this also has to be A. It's an isosceles triangle. Okay. All right. So those are both A. Those are the same. And now if I use Pythagorean theorem, so if I use my Pythagorean theorem here, what we get is a squared plus a squared equals the hypotenuse squared, x squared. So a squared plus a squared is 2a squared. That equals x squared. And I'm going to try to solve for the a. Divide the 2, and I get a squared equals x squared over 2. And then I can square root both sides. Square rooting this, I get a. Square rooting the other side, I'll get square root of x squared over 2. One thing to notice is I don't need a plus or minus because a is a length. So a cannot be negative. All right, so on the denominator I'll have square root 2. On the numerator I got square root of x squared. And remember that square root of x squared is absolute value of x. It's not just x, it's absolute value of x. Okay, so that's something that we've seen before. Okay, so that is absolute value of x. But in this problem, we can make a simplification. So x is a length here because it's the hypotenuse. So x is a length. X is a length, which means x is greater than 0. And if x is greater than 0, that means we're plugging in a positive number into the absolute value. So the absolute value just keeps it as it is. We'll just end up with x. Okay. All right, so we got x over root 2. That is the leg. Okay, so let me write that in. So my leg A is x divided by root 2. So same thing here. It is x divided by root 2. Okay, so let me separate out my work here from the picture a bit. So notice that these legs are just the hypotenuse divided by root 2. Okay, so I'm going to use that fact in this hypotenuse 1 triangle. The legs are just going to be the hypotenuse, which is 1 divided by root 2. They got to preserve that ratio. This leg as well, it's going to be the hypotenuse 1 divided by root 2. We could rationalize this denominator if we wanted to. And when we get to the unit circle, that's usually how we end up writing it. So 1 over root 2. 1 over root 2, if I rationalize that denominator, I multiply the top and the bottom by root 2. So root 2 over root 2, and now multiplying. So 1 times root 2 is root 2. And then root 2 times itself, well, that is 2. Okay, so I could also have written both of these legs as root 2 over 2. Okay, so nonetheless, so these are the sides in a 45, 45, 90 triangle. So the general relation is, whatever the hypotenuse is, I divide it by root 2 to get the leg. Or vice versa, if I know the leg, I multiply that by root 2 to get the hypotenuse. Okay, all right, so there's one other type of special right triangle. That is a 30, 60, 90 triangle. Okay, so I'm going to draw two pictures of this as well. So I'll draw a general picture. A general picture. So 30, 60, 90, so one of the angles is a right angle. One angle is 60 degrees, one angle is 30 degrees. So in my general picture, I'll call the hypotenuse x. And another picture where the hypotenuse is 1. Okay, so maybe this is a different size. But there's still a 90-degree angle, a 60, and a 30. But now I'll make the hypotenuse be 1. Okay, so let's get the missing sides of my general right triangle. So this one requires a little bit of geometry. What I'm going to do is I'm going to first draw another picture of a 60, 60, 60 equilateral triangle. So I'm going to draw equilateral triangle where all the sides are 60. And because it's equilateral, all of the sides will have the same length. I'm going to call it x. And now I'm going to add a line to the picture to make a 30, 60, 90 show up. I'm going to draw up from this top vertex a perpendicular straight down. And by the symmetry of the picture, that's going to split this top angle into halves. It'll make this be a 30, and it'll make this be a 30. So I get to put one tick mark like that because those are both the same. Okay, so this vertical length, I'm going to call A. So in my general picture of this triangle here, well, that vertical length here, that is my A. That is what I'm trying to determine. Okay. Also by the symmetry of the picture, this perpendicular line, it's going to cut that base into halves. So this, if this whole thing is x, well then half of that, from here to here, that's got to be x over 2. Okay, so let's do some Pythagorean theorem in this 30, 60, 90 triangle now. In this 30, 60, 90 triangle. Okay, so that's going to give us, let's see, we get x over 2, that's one of our legs squared, plus the other leg is a squared, equals a hypotenuse squared, x squared. And simplifying this, I get x squared over 4 plus a squared equals x squared. So let me try to isolate the a. Oh, in fact, one thing I can get at this point, one thing I should have labeled in my general picture is, I know what this base length is now. I got that was x over 2. So let's put that in. This length down here, this is x. Ooh, let me write that better. That is x over 2. Okay, what's missing is I just got to figure out a. So Pythagorean theorem is helping me with that. Okay, so let's isolate a. I got a squared equals, I'm going to subtract over the x squared over 4. So it'd be helpful to get a common denominator. So this x squared is 4x squared over 4. And if I subtract the x squared over 4 over, it'll give me 3x squared over 4. All right, and now I can square root both sides. And if I square root both sides, I get the square root of 3x squared over 4. All right, and then I can, because I'm multiplying and dividing everything, I can distribute the square root. And I'll get square root of 3. Square root of 4 on the bottom is just 2. The square root of x squared, well, just like before, that's going to give me absolute value of x. But I know here, because x is positive, since x is positive, absolute value of x just becomes x. Okay, so I'll get square root of 3, and then times x there on the numerator. Okay, so that is my side for A. It is going to be square root of 3 times x over 2. Okay, so how do I remember this? Well, if I have a 30, 60, 90, and I have the hypotenuse, well, the side opposite the 30, I have to divide the hypotenuse, divide it by 2, and that gives me x over 2. If I know the side opposite the 30, well, to get the side opposite the 60, this side, I multiply it by a root 3. Okay, that's just a trick I use to remember them. Okay, so what are the side lengths going to be in this hypotenuse 1 triangle? let's see if we can use this, this trick that I just indicated to get those side lengths. So if I know the hypotenuse, I divide it by 2 to get this side opposite the 30. So that'll give me 1/2. So I'm dividing by 2, dividing by 2. And then to get the side opposite the 60, I take this side and I multiply it by a √3. And doing that, I'll get √3 over 2. Okay, and those are the sides of a 30, 60, 90 where the hypotenuse equals 1. I kind of mentioned this briefly earlier, but one of the reasons in these special triangles, I'm drawing one where the hypotenuse equals 1, is later we're going to start to talk about trig functions in what's called the unit circle. And in the unit circle, we'll need to be able to handle triangles where this hypotenuse is 1. So these will show up all the time in the unit circle.